This differential equation looks even more interesting, and unfortunately we won't be able to solve it, but we'll at least be able to apply the existence and uniqueness theorems, figure out where they're having problems, and then try and investigate what those problems are and why they're occurring. We'll do that by drawing some solutions. All right, so first thing, we've got, f of x comma y, and so f of x comma y is discontinuous when, so it's whenever on the bottom it's 0. We're going to division by 0, and you get a division by 0 whenever x squared plus y squared is equal to 1. So that actually draws out a nice shape. So if I have the xy plane, it's a circle of radius 1 about the origin. So radius is 1. So it's discontinuous all along that circle. It looks like, if you're on that circle or you approach it, you're either going to get a positive infinity slope or a negative infinity slope, something like that, based on the y prime. But let's keep going. So that's the problem with f. So what about partial f, partial y? So partial f, partial y, well that's partial y, applied to 1 over 1 minus x squared minus y squared. All right, so to do that, I'm going to rewrite it as partial y of 1 minus x squared minus y squared to the negative 1 power. Okay, we'll take the derivative. It's a chain rule, so the negative 1 pops down, right? And then we're going to have 1 minus x squared minus y squared again. We're going to decrement the power to negative 2. And then we need to multiply by the derivative of the top, and the derivative of the top with respect to this partial derivative y. So that ends up being, well, the 1 turns into 0, the x squared turns into 0, and then the minus 2y squared turns into, the minus y squared turns into minus 2y. And if we kind of write all that out, the negative times the negative 2y will be a positive 2y. On the bottom, we'll end up with 1 minus x squared minus y squared. And so this one is having the exact same problem that f was having. Doesn't matter what y is, but we definitely have a discontinuity when we have x squared plus y squared is 1. So discontinuous when x squared plus y squared equals 1. All right, so we should have an existing and unique solution, and as long as, I forgot my n, as long as it doesn't start on this circle, we should be fine. So what happens? So I'll try and hand draw it here, and I'll show you a better computer one later. All right, x and y. So you have this circle of radius 1. So let me try and draw. Okay, that came out a fairly good circle. What ends up happening is you have all these curves. So some of them, I'm going to start over here. Some of them go around like that, and they keep doing that over and over again. And then there's other ones on the other side, and I think those go like that. Over and over again. There's more down here. But then you have others that are going to hit the circles. They go in, they hit the, and I need to make sure it has an infinite slope. When it gets to the circle, it'll have an infinite slope. So let's start with that one. So that's supposed to be infinite slope. If I go a little more, let's start here. Infinite slope. The line is supposed to be vertical. Let me try again. There we go. And it'll keep doing that. And I think, like, at the very edge here, you'll get one that's vertical. It goes up. They kind of all start getting smushed together. All right, and you'll have one that kind of, will not quite be vertical, so I need to draw that. So, but it barely misses the circle. And so it ends up going, down here, joining these curves, kind of the boundary. But then on the bottom, I definitely didn't leave enough room. There's going to be, vertical stuff down here too. And so that's when it hits the circle, but then when it gets inside, it'll actually go, and let me draw like this one. It goes down, it's vertical, and then it does something like that, and it might, join down there, and it goes to another one. If I got another, it would be vertical, something like that. And vertical, it's supposed to end vertical. But that's the idea. And so, unfortunately, I don't know how to solve this one, but these are what the solution curves look like. And the problem is, when they're going down this way, they have this greater and greater negative slope, eventually get to the negative infinity. But then the slope kind of becomes positive infinity because this slope here is positive. Then it goes back down to, back to positive infinity. And then it essentially has negative infinity again, and then it keeps going. So that's what the existence and uniqueness theorem kind of warned us about. And we don't have the actual solution. So, we can't tell if maybe, we can repair these somehow. But that's how this ordinary differential equation works out.